All right, so now that we kind of have looked at ions, monatomic, polyatomic, cations, anions, and discussed how ionic compounds form, we're going to now talk about how to name ionic compounds. So nomenclature means naming. So the nomenclature of ionic compounds is pretty easy, honestly. It's the name. You take the name of the cation, the positive ion, and the name of the anion, and you put them together. And that's it. You don't put anything else there. So name a cation, name an anion. Because that's really all we need. So we only need those, and we can figure out the formula and all that. So when we name cations, the main group, basically most of the main group element cations, at least the first group, the second group, and the third group, the one with aluminum, they're simply the name of the metal plus ion. Like Na plus the sodium ion, Ca2 plus the calcium ion. The aluminum ion is Al3 plus. Okay. When we get to the ones that are in the transition metals in that area, the ones that can have more than one ion, we have to tell you, when you write the name of it, you have to tell what the charge of the ion is. And we do that by using this parentheses with Roman numerals in it. So, for example, Fe2 plus, that's the iron ion that has a 2 plus charge. We write as iron, we call it the iron 2 ion. Notice that we put parentheses and Roman numerals for the charge. So it's 2 plus, so the Roman numerals are 2. Also notice there's no space between the last letter in the name, the metal name, and the first parenthesis. So the iron 2 ion is Fe2 plus. So another iron that's stable is Fe3 plus. And that would be, when we name it, it would be the iron 3 ion, because that 3 tells us the charge of the ion. Okay, and then other examples, copper has 2 main ions, copper 1 plus and copper 2 plus. So the copper 1 plus ion is called copper 1, with that Roman numeral 1 in parentheses. The copper 2 plus ion is known as the copper 2 ion, and it's got Roman numeral 2 in parentheses. Tin has 2 stable ions, a 2 plus and a 4 plus. So Sn2 plus, we call that the tin 2 ion, so that there's Roman numeral 2 in parentheses. And then for tin 4 plus, that's the tin 4 plus ion, where the Roman numeral is IV. So remember, when you do the Roman numeral for 5 is V, and when you do the number before that, 4, you put a 1, an I, next to a V, and you get IV. Okay, and then the silver ion, which is in the transition metals, really only has one stable ion, and that's Ag+. Okay, so that's why we don't call it silver 1. It's not wrong to put silver 1 there, because it is a transition metal, and there is a silver 2 ion. It's just not very common. So the ones that have more than one ion, that's very common, is when we use the parentheses. So basically, anytime you see a metal from the transition metals, put the charge of the ion in parentheses when you name it. Okay, there's a few that we don't usually do that for, silver, zinc, but since this is an introductory course, if you have a transition metal, put its charge in parentheses. Okay, and then we have the 2 cations that are polyatomic, and really it's only the ammonium 1, NH4 plus, that ion, that we're going to have to worry about in compounds that we're dealing with. Okay, and then the anions. So if we have a single element like Cl that becomes an anion, Cl minus, we name it by putting an IDE at the end of the name of the element. So Cl minus is called the chloride ion, IDE at the end. The ion of sulfur is S2 minus. We call that the sulfide ion. Okay, so if we look at other ones like Br minus, is called the bromide ion. O2 minus, the ion of oxygen, is called the oxide ion, and so on. So if you just basically have a single element that's forming an ion, we just put IDE at the end. Okay, and then we have the polyatomic ones that you need to know, and you can see their formulas and their charges. So you need to know the formula and the charge of these ions. Nitrate is NO3 minus. Nitrite is NO2 minus. So when you're dealing with anions that have oxygen in them, like this, one other element in oxygen, you're going to have one that ends in ATE. That's the most common one. So like NO3 minus is called nitrate. And then if you remove an oxygen from there, but the charge stays the same, it's called nitrite. It ends in an ITE. Okay, so that's pretty common to see, like sulfate and sulfite. Sulfate is SO4 with a 2 minus. Sulfite is SO3 with a 2 minus. All right. Carbonate is SO3 2 minus. Or sorry, CO3 2 minus. So carbon with 3 oxygens with a negative 2 charge, so it gained 2 electrons. Hydrogen carbonate is simply just adding a hydrogen and H plus to that. So if I add H plus, I get HCO3. Ooh, that should be single minus. There shouldn't be a 2 there. It's HCO3 minus. Crap, did I do that in the previous one too? I'll have to go back and look. So HCO3 is a single minus, hydrogen carbonate. It's also called bicarbonate. Like sodium bicarbonate is baking soda. So that's the ion that's in baking soda. Okay, and then you can see the other ones. Hydroxides are typically bases. We'll see that later on in the semester. So these are the ones you'll need to know. All right, so when we name ionic compounds, the best way to do this is identify the cation and identify the anion, and then name them. Okay, so LiNO3, Li plus is the metal in here, and it's a positive 1 charge. NO3 minus is the anion. That's the polyatomic anion we just saw. So Li plus, it's in the first column. The alkaline metals. So Li plus is the lithium ion. So we're just going to put lithium. NO3 minus is nitrate. Nitrate. So LiNO3 is known as lithium nitrate. Okay, going down. So we can see we got parentheses. So that's going to be the cation in those parentheses. So we're going to have Mg. Magnesium is, when it's an ion, magnesium is in the second column. So it's an alkaline earth metal. All alkaline earth metals ions are 2+ ions. So it's Mg2+. And HCO3 minus. That's Mg2+ is called, that's a plus, not 21, is called the magnesium ion, so magnesium. And HCO3 minus, if we go back to our table, is called hydrogen carbonate or bicarbonate. You can put either. I'm going to put hydrogen carbonate. So magnesium, hydrogen, carbonate. So this formula is magnesium hydrogen carbonate. Okay, NH4,2SO4. So we can see we have a polyatomic ion here, NH4. So we have NH4 plus and SO4. And SO4 is a 2 minus. You'll know because you have to memorize. So NH4 plus is ammonium. And SO4 2 minus is sulfate. So ammonium sulfate is that guy. Okay. FeOH3. We can see we've got a polyatomic ion here. And there's 3 of them. So an iron is one of those metals. It's a transition metal. And it can have more than one ion. So there's an Fe2 plus and an Fe3 plus. We need to figure out which one it is. And we figure that out by the anions. So our anion here is OH minus. and there's 3 of them. So overall I have 3 negative charges. And there's only 1 iron, so that 1 iron has to carry 3 positive charges to match with the 3 negative charges. So the it's going to be Fe3 plus. That balances off the charges on the 3 hydroxides. So when I name this, remember we have to put the charge in parentheses using Roman numerals. So it's going to be iron 1, 2, 3, Roman numeral 3, iron 3, hydroxide, because OH minus is hydroxide. Wow, that looks awful. Hydroxide. So iron 3 hydroxide is that formula. Okay. So we got our metal here, Sn. Sn is tin, and it has 2 stable ions, 2 plus and 4 plus. We have to figure out which one it is. And then this is the oxide ion. The oxide ion is O2 minus, and there's 2 of them. So I've got overall 4 minuses, right? Because there's O2 minus and O2 minus. So, because there's 2, remember, oxide is O with a negative 2 charge. And there's 2 of them here. So that means I get an overall 4 negative charge. So that means my Sn must be 4 positive. So because tin has 2 stable ions, we got to make sure we put the charge in parentheses. Tin 4 IV oxide. Okay. And the last one, we have our copper and PO4. PO4, the PO4 ion has a 3 minus charge. You'll memorize that and know that. That's phosphate. And the Cu, copper has 2 stable ions, a 1 plus ion and a 2 plus ion. Okay. So since phosphate has overall 3 negative charges, and there's 3 coppers, each copper must have a single plus, so that when there's 3 of them, I got 3 total positive charges, and that balances off the 3 negative on the phosphate. So this is going to be copper 1, because it's got a plus 1 charge, phosphate. So that's how you go from formula of the compound to the name of the compound. Find the cation, find the anion, name them, and put them together. Okay? What if we go the other way? What if we're given the name and we need to come up with a formula? Well, the barium, it tells us what ions are in there. The barium ion, Ba2+, because it's an alkaline earth metal. It's in the second column, it's got a 2 plus charge. Fluoride is a halogen. Fluorine's a halogen. It's in the column next to the noble gases. Those are all single negatives. So I've got Ba2+ and F-. I got to make it neutral. So I need 2 fluorides to balance off the 1 barium. So I'm going to write it as BaF2. Okay. Copper 2 sulfide. So this is kind of nice when they do the transition metal and they give you the name because you know the charge. Copper 2 is Cu2+, because that's the 2, right? The 2 tells me the charge. Sulfide is S2-. Sulfur's in the same column as oxygen. Oxygen's a -2, or got a -2 charge or 2- charge, so does sulfur. Since they're the same, when I put them together 1 to 1, the charges will cancel each other. So I just need Cus, and that's copper 2 sulfide. Sodium carbonate. Sodium is Na+. Carbonate is CO3 2-. So I can see that I'm going to need 2 sodiums to balance off the 2 negatives. So my formula is going to be Na2CO3. Sodium carbonate. Iron 3 hypochlorite. Iron 3, again, it tells us the charge, Fe3+, because that 3 means the charge. hypochlorite was ClO minus. So I can see I've got 3 positive charges, and each hypochlorite is only 1 negative charge. So I need 3 hypochlorites to get 3 negative charges to balance off the 3 positives from the iron. So I've got 1 iron, Fe. I'm going to put parentheses, ClO, the 3 outside. So that's telling me I need 3 hypochlorite ions for every 1 iron 3 plus ion. Aluminum acetate, Al, 3 plus. Acetate is CH3, CO2, CH3, CO2 with a negative charge. Again, aluminum has 3 positive charges. Acetate has a single negative, so I'm going to need 3 acetates. So Al, parenthesis, CH3, CO2, and then outside I'm going to need 3 of those. So I need 3 acetate ions for every 1 aluminum ion. Lead 4 cyanide, remember lead is Pb. That 4 tells me the charge, 4 plus. Cyanide is Cn minus. So lead 4 cyanide, I'm going to need 4 cyanides. So Pb, parenthesis, because I got a polyatomic ion that I need more than 1 of. So Pb, parenthesis, Cn, 4 on the outside. Because I need 4 cyanides to get 4 negative charges to balance off the 4 positives from the 1 lead. Last one, magnesium phosphate, Mg2+. Phosphate is PO4, 3 minus. So now I've got 2 magnesiums with a 2+, phosphates with a 3 minus. So I'm going to need 3 magnesiums, which is going to give me 6 positive charges, and 2 phosphates, which is going to be 6 negative charges. So I'm going to write Mg, I need 3 of those. Phosphate, PO4, parenthesis, and I need 2 of those. So magnesium phosphate, Mg3PO4. So that's how you name ionic compounds, cation, anion. You just got to know your names of your cations and your anions.